Good afternoon, ladies and gentlemen, esteemed speakers and honored guests. Welcome to the third session of our captivating series on concept of time in quantum theory and Arya Nagarjuna's philosophy. I'm Kama Zumba and thrilled to be your moderator for this insightful and inspiring event. For this session, we have an excellent speakers along with our chairperson, Professor Kauri Gilla, non-resident senior fellow at the Center for Excellence in Himalayan Studies, School of Humanities and Social Science, Shiv Nadar University, Delhi, professor and head of department, followed by our speakers, Assistant Professor S. Aravinda ji, Mr. Lotus Namgail, and Dr. Dinzi Rabanda. Our distinguished speakers today bring a wealth of knowledge and expertise on the table. Now I would like to welcome them on the dais, our chairperson, Professor Kauri Gilla, Assistant Professor S. Aravinda ji, and Mr. Lotus Namgail. Thank you. Now please allow me to briefly introduce our chairperson. I'm not head of department. Okay. Sorry for my mistake. Actually, Dr. Kavira is not an head of the department. Sorry. Okay. Now please allow me to briefly introduce Professor Kauri Gilla. Professor Kauri Gilla is non-resident senior fellow at the Center for Excellence in Himalayan Studies, School of Humanities and Social Science, Shiv Nadar University, Delhi, formerly professor at the Department of International Relations and Governance Studies. She gained her doctoral degree from the University of Cambridge, United Kingdom, and subsequently taught there. By invitation, she served as the principal of the Dalai Lama Institute for Higher Education, Bengaluru, from 2021 to 2022. Kaurila has actively studied Nalinda Buddhist philosophy for the last decade, and on 2nd June 2023, in a convocation ceremony presided over by His Holiness the 14th Dalai Lama, received an advanced postgraduate diploma, Nalinda Master's course in Buddhist philosophy from Tibet House, New Delhi. In addition to courses in her discipline of political economy, Kauri Gilla has taught three editions of an undergraduate course filled to capacity entitled Secular Ethics for Millennials, based on His Holiness' idea of universal ethics, and focus on teaching the importance of practicing wisdom and compassion in daily life. Now I request Professor Kauri Gilla to lead the session.
Tashi Dele, good afternoon. So I would like to thank Venerable Geshe Dorji Damdullah and Tibet House for asking me to chair this session. Actually, I'm standing in for Professor Rana Purushottamji. So it's a great honor to be here and part of such a profound conference talking about so many things that are so central to our experience as sentient beings. So this panel is going to be on the concept of time in quantum theory and in Arya Nagarjuna's philosophy. So when we look at the notion of time, it is so central to our lived experience, and as I said, our sentience and even our suffering. For example, as the Buddha Shakyamuni said about aging and death. Geshe-la was making jokes about our age, but I think when we confront things like, for example, the death also of loved ones, near and dear ones, our entire experience relates to time. And on the positive side, we can also think that, had we lived in the time of Buddha Shakyamuni or Arya Nagarjuna, and by some accounts, they are still there, always there at present, but all of these relate to the notion of time. So when we think of a standard working definition of time, which we can debate again as in so many sessions, so I think something that we could accept is that perhaps we can think of time as a gap between two consecutive non-simultaneous events. In the morning, Professor Geshe Nawang Samthinla spoke about time, the notions in non-Buddhist schools and in Buddhist schools. So again, within the Buddhist schools, the Vaibhashika and Prasangika Madhyamika, so the lowest school and high school, again, as explained by Venerable Choing, not because of any other thing, but because of their understandings of, ontological reality might be subtler as you go along these schools. But these two schools agree that the 3 times are impermanent and they are functional phenomena, whereas the other schools in Buddhist philosophy, the Chittamatra school and Sautantrika, they believe that the past and the future are permanent, whereas only the present is impermanent. So there is debates about that within the Buddhist schools. And then, as Professor Samthinla said in the morning, that for the Buddhist schools, time is not an independent, substantial reality. Rather, it is a quality of product. He used the Sanskrit term for it, I think Sanskrit Dharma. So look, Sanskrit scholar as well as being, of course, a Nalanda scholar and Tibetan proficient to high excellence. So product which can also be taken as composite phenomena. So it is a quality, time is a quality of that, whereas the non-Buddhists might say that time is an independent substantial entity of its own. So Nyaya, Vaishashika and others. And I will just touch upon, because our first speaker, unfortunately, Professor Nilsala, is not able to be here. She was not well. She was going to talk about Arya Nagarjuna's philosophy, perhaps the greatest interpreter of the Buddha's words on the nature of ultimate reality. So just to touch upon how time may be understood from the perspective when he interprets about the Prasangika Madhyamika's understanding. So we heard throughout the morning about conventional truth and ultimate truth, the two truths. And if we start looking for time at the using ultimate analysis, as Geshe Dorji Damdolla's slides showed, when we look at the ultimate truth, we are using the frame of ultimate analysis, and when we are looking at the conventional truth of our everyday lived experience, it is through the lens of conventional analysis. So if we go looking for the 3 times, if we go looking for the present, no doubt we all have to accept that the present does exist. We are all sitting here in a Tibet House conference. Events of Gaza and all are happening as somewhere else in the world. All of this, the present moment certainly exists. But if we go examining more deeply, how does it exist, we cannot find it. So if we think about, if we just do this simple exercise, and Arya Nagarjuna said, so when he's talking about the ultimate nature of things as opposed to the conventional nature of things, if we go closer to examine that, what is the nature of time, for instance, so he cites that if the mirage were to be really water, then why not those close to the mirage see water? So if we go into the ultimate analysis of going closer to the object and trying to find where is this present moment, we are not able to come up with a concrete moment. So so therefore there's a discrepancy between our understanding of how things appear and how they actually exist. And when there's such a discrepancy, then they may be termed illusion-like. So if we think about, like, if we go searching for a present moment, if we take an instance of 1 second, every moment of time, it must have a beginning, middle, and end. So if we take it as 1/3, 1/3, 1/3, we then have to break up each moment further into a middle, beginning, and end. This goes on ad infinitum. So you cannot actually pinpoint something called the present in this ultimate analysis frame of going closer, and trying to see what really exists there. If the referent of this present moment is not findable, then of course the past and the future doesn't make sense, because they can only exist in reference to this. So then what you're saying is that the 3 times are illusion-like, because there is a discrepancy between how it exists and how it appears. Something that does not exist the way it appears, it is illusion-like a mirage. So in this instance, time is illusion-like. Therefore, everything that exists in time, including our minds, And everything else that we experience as sentience also is illusion-like. So with that small little introduction, and pardon all my mistakes because this is just a little bit of last-minute thinking for this session. I really look forward. We have excellent speakers with us. And as I shared, Dr. Nilza could not be here today. So our first speaker will be Dr. Aravind, who has a PhD degree in the area of foundations of quantum mechanics, 3 postdocs in quantum information theory, quantum many-body theory, etc. Currently, he's a faculty at the Department of Physics, the Indian Institute of Technology at Tirupati. He works in the area of quantum information theory, quantum computation, and quantum matter. So welcome, and you have 15 minutes. Yeah.
Thank you. First of all, I would like to thank Geshi Dorji Damdulji and Professor Sushil Roy for inviting me here. And thank you. From the morning, there are so many interesting talks. And we begin. In this talk, I am going to briefly touch upon what is, how do we perceive time from the perspective of a quantum physicist. And I might be able to cover 1 or 2 topics briefly. First of all, when we say the time, we all know that we experience time at whatever the level we are in. That means there is a past, present, future, we get old, and this is a very, very nominal understanding of what time means to us or any common people, and most of our economy, sociology, everything depends upon this one unidirection of the time. So then, from the perspective of a quantum physicist, does such a unidirection of concept of time is it exist, or if it doesn't exist, how are we able to see that unidirection of time? These are the some questions which was bothering me from a few years, and I would like recently I was able to tackle these questions in a related way. These are the two of my collaborators, and this is the technical paper. Leave it. So. Okay, there is a difficulty in understanding the quantum theory, I know that, but I try to introduce the quantum theory in 1 minute. So imagine there is this is an experimentalist. Okay, there is an experimentalist doing his experimentation in the laboratory, and a nice theorist enters, and experimentalist asks the question that what can you say about by looking into the tabular column, that means by looking into the probability distribution which I am giving to you. I have a sheet of whatever the inputs I have done, what and all the experiment I have done, and I give these sheets to you, and what can you say about what system I have used in the experimentation? I am not allowed you to open this box. Can you say anything about the system which I have used in this box? So this question is very prominent in the sense that this is this set up one framework. This sets up a framework which we call as an operational theory framework, and in fact it has an origination from John Bell. Professor Atul has explained everything in detail about the probabilities and the Bell's theorem, and in fact it has origination. What do I mean by? So we in this slide, in this picture, I am proposing a idea that whatever we study is an operational theoretic perspective, and quantum theory is a mathematical formalism of a minimal descriptive formalism of whatever we observe. In a simple example, if I wanted to model the entire traffic of Bangalore, sorry, I know Bangalore very well, so I am using the Bangalore example. If I wanted to study the traffic structure of Bangalore, I have a data of all the buses at all the locations, and I wanted to bring up the easiest, simplest theory which will exactly predict at this time where the buses will be. This is what my interesting stuff is, and quantum theory is able to do that at the subatomic stage, and from last 130 years, it's not even a single experiment is able to disprove the predictions of the quantum theory. So what are the basic elements of the quantum theory? It's always there is a one preparation, something which you are preparing a state, and then you are evolving something, you are transferring, and then ultimately the most important aspect is that you are making a measurement and you get the probability distribution. So this is what one does in an experiment, and what you are trying to develop is a mathematical formalism for this explanation, and quantum theory is a mathematical formalism. This is the 1 minute introduction to quantum mechanics. Okay, so now the concept is what is time. When I ask the what is time, the frog answers that don't you know about the second law of thermodynamics. So most of you people at least heard about the concept called entropy, which basically says that time is flowing in one direction, or we are all aging. Okay, so once if I from the morning we had a breakfast and now nice lunch also, and I can't go back to lunch. Even in the lunch, Amdulji offered me a nice sweet, but now I am planning to eat that, but I cannot go back and do that. So essentially the second law of thermodynamics says that you cannot go back. That means there is a direction. Well, but the dynamics in the quantum theory is perfectly reversible, in the sense that if the governing laws of nature is quantum theory, then the laws at the fundamental level, at least in the quantum theoretical level, which is what I am more focusing on, are reversible. That means, then there is the two fundamental questions emerged. One is at the microscopic description. What do I mean by microscopic description? I have a cup, and then I throw the cup, and the cup shattered. So and then you cannot make a cup back. Okay, so this is the one direction. The time has flown in one direction, but the dynamical laws are reversible for each and every particle. It is not, but at in a emergent, if I use the words, in emergent phenomena, it is moving in a one direction. So where does these laws come from? So this was the question is being bothering and bothered from approximately from 1900. So when Ludwig Boltzmann formulated the statistical mechanics, even currently the foundations of statistical mechanics is trying to understand how does this emergent unidirection of time emerged from a kind of directionless, time directionless unitary dynamics of quantum theory. So that is the question, and that question is people have been asking, and there are various answers, debates. This is nothing to say that this is the end of an answer, whatever I am proposing, or it's not like that. There are various answers, debates, because it's a century-old problem. But for this, let me define let me again tell you again, what is the question is that at the subatomic level, you can kind of say that there is no time. So because there is no unidirection, but at the macroscopic level, you are seeing the unidirection of time. So where does this comes from? This is the question. So for that, don't much worry about the mathematics which we have defined here. I am a theoretical physicist. I have to show one equation, otherwise I am not satisfied. So I have to put an equation. So I put this. So basically, this is what is called observational entropy. This is called the observational entropy. Originally proposed by von Neumann in 1930s, but recently people have started to look into this entropy. This is one kind of entropy. The major problem is that in physics, in quantum theory, we don't know how to define an entropy. Like classical very well defined, but quantum there are problems. Okay, so you can think about what do I mean by coarse graining. There is one concept you need to remember in the whole discussion in this slide, which is what is called coarse graining. What is coarse graining? For example, here I have 1, 2, 3, 4, the 4 boxes, and these are all the probabilities. If I throw the particle in these 4 boxes, what is the probability which you are going to get the particle in the box 1, box 2, or box 3, or box 4. These are the perfect. I can perfectly know if I throw this one, what is the probability with which I can find out. My instruments are so perfect. Okay, so what? Now there is a 2 types of coarse grainings which I have defined here. Means 2 types of observations in a very naive way. Here I am in the C, in this one, I am able to distinguish whether the particle is in the 1, 2, 3, 4. Any of these 4. Whereas this is another type of coarse grain measurement where I don't have the complete understanding. I don't have the complete capability to say whether the particle is in 1 or 2 or 3 or 4, but I can definitely say whether it is in the left half. That means either it is in the 2 or 1 or 2 or in 3 or 4. That means my measurement ability to distinguish is being reduced. So this is what is called the coarse graining. That means I am increasing my coarse graining. In other words, my measurement incapability is increasing. So there is a beautiful theorem which says that as the entropy increases, as the coarse graining is increases, my entropy increases. So what is so different with that? Why should I need to bother about them? So this, whatever the form which is showing here, which is a coarse grained, this is the coarse grained entropy, this is von Neumann entropy. What you need to know about this one? The black color one says what is the uncertainty about the preparation, whether I am preparing a red ball, blue ball, or whatever this. So what is my uncertainty? And the red color one is saying that what is the uncertainty which is coming due to my measurement incapability. I don't have the capability, my instrument doesn't have the capability. And the beautiful thing is that this difference gives the measure of irretrodictability. This is the one concept which I wanted to say clearly. What do I mean by irretrodictability? This comes from the probability theory called the Bayesian analysis and other things. So let us go very briefly that I have a forward direction, that is x and y. These are the 2 things. What I mean by forward direction is that the event x happened now and y later. Okay, so this is the forward direction, and there is some event happened, and I know by looking into the event x what is the probability of y. I can predict that. This is what is called the prediction. So another one is retrodiction. That means after happening this event, what is the probability with which I can retrodict the past? Both things are very common in physics. For example, retrodiction is very common into looking into your astronomical data. You are able to retrodict what has happened some 100 years ago or other things. And also prediction is very common, as you already know that. So this is a common thing. So what is the this is what is called forward probability and reverse probability. And what this is giving measure of irretrodictability. Means given the current situation, how well I can retrodict the past. How well I can, in other words, this irreversibility, whatever I am dropping the glass and then it's broken out and I cannot get back the cup, is kind of how difficult is to retrodict. This entropy differences is giving me the measure of irretrodictability. So why it is so? So the entire thing I would be able to express in this 3 picture. So one is The answer to this question which I have raised in the beginning is that one is because of coarse graining, that is I don't have the control over all the details, each and every atom's control. This is the one thing which is what termed as the coarse graining, measurement incapability, and associated with something called chaos. You must have heard about that. You cannot, the system is so chaotic, you cannot determine its initial position. Even though it is deterministic kind of thing, it is not possible. Such coarse graining, and which gives rise to what is called irreductibility, along with chaos, gives rise to the concept of the whatever irreversibility, what we call in the macroscopic world. That means you can see a direction of time. Time is flowing in one direction, so it is moving from here to here. So in effectively what I mean to say is that, so the time kind of emerges from the timelessness due to our observer's incapability associated with systems chaotic nature. So that's one thing I could say. In fact, in this way, actually in the morning, Geshe Samtenji has whatever his words, if I quote, that nicely fits it. Time is the property of the product. I would also extend, time is the property of kind of observation, property of the process. So, but ultimately, at least in this type of understanding, I would say that time is an emergent phenomena of an observer. So, it is emerging. The time, quote unquote, the time of one-way directions kind of time is the property of an observer. I don't take more time, so just 2 slides. This is not my work, so I have been just doing recently the Bruckner's group. This is the relativity of the time dilation. You must have all know that, for example, if this guy is the rest frame and this is the rocket which is a moving frame, there is the 2 events. This is one event differentiated by some time window. So, and then for a rest frame, this time window is one thing, and then if it is moving, it time delays. That means it reduces. This is what one concept from special theory of relativity, which revolutionized the time, which Abhishek put it in the morning. But if these things, if we instead of if I imagine this, the entire frames of reference as a quantum, the whatever he was explaining, it is the classical level. If we assume everything is a quantum, what would happen? So, for example, here is a sitting rest frame, and the frame which is moving is in a superposition. The entire frame which is moving in the superposition. Then what happens to this time delay? It is kind of interesting that the time delay itself, there are the 2 time delays. That means the time delay is in the superposition, what Professor Atul was telling. So you have already seen the superpositions. So like that, now not only the properties are in superposition, the entire time delay is in the superposition. That means the time delay itself is indeterminate. So there are further many interesting features about time, causality, and other things which is recently is happening. I just wanted to show these are the 2 things which how dramatically changes our concept of time from the quantum theory. Thank you.
Thank you, Dr. Aravind, for such a lucid presentation and for making accessible to us what quantum theory has to say about time. And it has to be said that since the morning, if we look at each of the sessions, the discussion on the microscopic and macroscopic reality, what is conventional truth, what is ultimate truth, what is the role of the subject, what is the role of the object, and then as you have also given an added definition of time, that it is actually also a property of the observer. You've highlighted what Arya Nagarjuna's entire philosophy is about in terms of his exposition on the Prasangika Madhyamika view, which is about 100% subjectivity and observer bias in that sense, a creation. With that, we turn to our next speaker. So we have Mr. Lotus Namgail. He's currently a senior research fellow in the Department of Philosophy at Punjab University, Chandigarh, pursuing his doctoral research work in the field of Buddhism and modern science, especially the literature concerning dialogues between the two disciplines. Before joining the PhD program, he used to teach Indian philosophy in Delhi University's college as an assistant professor ad hoc. He pursued engineering for his bachelor's degree from NIST, University of Delhi, after which he did his Master of Arts in Philosophy, and since his college days, he has been studying Buddhist philosophy at Tibet House through its various programs under the guidance of Geshe Dorji Damdula. Over to you.
Thank you so much. Thank you so much. Good evening, all the respected scholars. It is indeed a great honor for me to get this opportunity to speak in today's conference on quantum physics and Buddhist philosophy. I wholeheartedly thank Geshe Damdullah and the entire Tibet House team for organizing such an insightful and interactive conference. With the dynamic advancement in modern science regarding the outside world, we have stumbled upon a unique turn of events in the form of quantum physics that has completely mesmerized the world with its charm to unlearn, unsee, and relearn many things which we always took for granted. This unlearning, which is in fact a new learning in itself, provides us with a new platform to relook into the treasures of age-old knowledge, but with newer flavors. Such a mind-opening unlearning, if I may call it as, was taught by Arya Nagarjuna as well, wherein he taught us to challenge our conceptual constructs and views, thereby motivating practitioners to see beyond conceptual dualities. I call it unlearning because Arya Nagarjuna made us question the rigid concepts. His philosophy helps us break the molds of our own views. Well, my endeavor today will be to carry out a critical analysis of time, especially under the light of Arya Nagarjuna. A critical analysis of notion of time for me is indeed a very, very complicated process, because for this I have to step beyond the usual comprehension of notion of time. In the usual within this usual comprehension, we have the idea of an arrow of time, as everyone was, Professor Aravinda was also telling us that there is an arrow where there is an idea of past, present, and future. Though quantum physics and theory of relativity has revolutionized commonsensical understanding of nature of reality, Buddhist scholars, I think, seem not to be too surprised with these findings, because they have been discussing such debates, they have been discussing such intense debates since time immemorial, through Nalanda tradition that was very much refined in Tibet by great masters. The 19th chapter of Mool Madhyamika Karika, Arya Nagarjuna takes a very thorough discussion on notion of time, first by considering the possible relation between three phases, the past, present, and future. The chapter employs reasoning to ascertain that the three times have no nature. I will try to explain my limited understanding with minimal technical terminologies. In verse number 1 and 2, there is refutation of the possibility that present and future exist in dependence on the past. The first verse goes like this: if the present and future depend on the past, the present and future exist in the past. Well, it is argued that if present and future exist depending on the past, then present and future would be the past. In other words, Arya Nagarjuna explicates the absurdity of the fact that the entities that are existing now and the entities that will exist later have both existed in the past. A rough representation of the first verse would be like, if present and future depends on the past, then past equals presence. Past equals present. That is, present is not only present in the present, but also in the past. Secondly, past equals future. Future is not only present in the future, but also in the past. In yet other words, if it is accepted that present and future is dependent on past, then it is somehow same as saying that everything that is happening in today's conference had been held in the past. As it is happening now, as we can experience it, and it will a complete replica will happen in the future. This is absurd. If more so, someone is watching our conference from say a distance of 1 light year from this conference room, he will experience this present now after 1 year. So our experience of the present moment and his experience of the present moment of the same event are different. Therefore, an objective present moment is again questioned. Then comes the second verse, which goes like this. If the present and future do not exist in the past, how can the present and future be dependent on it? As the presence of present and future in the past was shown to be absurd in the first verse, one might as well argue that present and future do not exist in the past, but then such a dependence does not exist. It simply means that both the relator of the dependence must be present, or else dependence is not feasible. A somewhat similar argument has been forwarded by Arya Nagarjuna while rejecting causality as inhering a swabhav, causality as inhering an intrinsic nature, wherein it is argued that one of the relata of causality, be it the cause or the effect, is a conceptual construct, because when the cause is there, the effect is anticipated, and when the effect is there, the cause is supplied by the memory. Arya Nagarjuna is not refuting the conventionality of causality and time, but he is refuting the swabhav that is said to be there within causality and time. He is refuting the intrinsic nature of time, intrinsic nature of causality. Arya Nagarjuna then shows the dependence of present and past on the future at conventional level in the very next verse. If present and future are not dependent on the past, neither of the two would be established. Now he is showing the conventionality. If future, for instance, is an independent part of time, then it will never become present, or the past, which is not true, because at one point of time, future becomes the present as well as the past. Therefore, present and future are not established completely independent of the past, because time is conventionally experienced and explained as an arrow, where the present and future is always subsequent to the past. Conclusively, present and future can neither be established in dependence nor independently of the past. Therefore, present and future do not exist in a real sense and are not intrinsic features of time. Well, to contextualize the next verse, the fifth verse, I would like to draw the attention towards the most famous theory of relativity. Everyone was talking, Dr. Majhi was also talking. Just like the notion of absolute notion of time is challenged by Arya Nagarjuna, we find instances of this in modern science too. If today's conference, let's say, if today's conference were to happen in a spaceship traveling at a speed of light, let's say 80 or 90% of the speed of light relative to Earth, then for a person observing from Earth, it would take more than 1 day for the conference to finish. This is beautifully explained as twin paradox, which shows that time appears to pass more slowly for an observer in motion with respect to a stationary observer. It shows that time interval depend on the relationship between object and the observer. This challenges our intuitive concept of time as a universal constant. Duration of time, therefore, I guess, lacks inherent existence. On this, Arya Nagarjuna, in the fifth verse of the chapter 19 of Mool Madhyamika Karika, states that a non-abiding time cannot be apprehended. An abiding time that can be apprehended does not exist. And how is a non-apprehended time conceived? This is interesting because for me, Arya Nagarjuna's chapter on examination of time in Mool Madhyamika Karika, which otherwise is very hard to visualize, becomes a little more visualizable and easier with, at least for me, to grasp from inputs like Einstein's special theory of relativity and other scientific achievements. That's why I think such dialogues are very, very important. I'm positive that more research in the domain of quantum physics and theory of relativity or quantum gravity, I think they will provide even more insights into the notion of time, and such dialogues will definitely fulfill the dreams of His Holiness the Dalai Lama. Let's move to the last verse of the chapter of Arya Nagarjuna. It is said, it is said that within the Copenhagen interpretation of quantum physics, particles exist in superposition of states until measured, but upon measurement, wave collapses and a specific state is realized. The definite properties of the subatomic particles then get defined. Before that, there is no definite definitions of space-time of the subatomic particles. the temporal characteristics also get defined after the measurement. This brings us to the measurement problem that has been obviously widely described around the world, and even the philosophers of science have been discussing the measurement problem at various instances and trying to bring different conclusions. But my concern here is whether the evolution of probabilities depicted over time in Schrödinger equation prior to measurement infers the objectivity of time, especially in the absence of measurement. This thin line where a definite space-time properties of subatomic particles cannot be defined prior to measurement except for the mathematical formation in terms of probabilities has a lot of philosophical concern regarding the nature of reality. The debate that whether this is how the nature really is, or is it some human limitation, or there is some more things to be unveiled with more advancement in technologies or human knowledge. This debate will go on and go on forever. In quantum physics, we have also learned that the reification of intrinsic nature causes various logical inconsistencies. This brings us to the next argument of Arya Nagarjuna on notion of time. If time depends on things, then how can there be time if things do not exist? And since there are no things at all, how can time exist? Arya Nagarjuna then argues that if time is based on entities, it is once again fallacious because entities are also empty of inherent existence. Arya Nagarjuna has shown the absurdity of such claims that entities exist essentially in different other chapters of Mool Madhyamika Karika and in other texts as well. It is once again interesting to note that quantum physics has also challenged various classical concepts, but still those challenges and new discoveries are mostly expressed in classical language because we comprehend classical language very easily. And most of the instruments also doing the experiments are somewhat classical in nature. I find a similar concern in Arya Nagarjuna's Two Truths, where he speaks that without relying on the convention, the ultimate cannot be shown. Well, the idea is not to assert that quantum physics is the ultimate truth, which Geshe Damdullah was also explaining, but the analysis done in quantum world are at various instances similar to the ultimate analysis done by Buddhist scholars. Well, at the end, I'd like to bring up a simple rhetorical question for today's participants to think upon, which will help us to question the nature of time, because for me also, the analysis of time is a very complicated process. I think, therefore, this question can help one in one way or the other to start the analysis of time. The question goes like this: Is it possible that you yourself are the clock? And this reminds me of a verse from a poem by a great poet, Javed Akhtar, a contemporary Indian poet. I'll read it in Hindi. The translation is here. क्या ये मुमकिन है कि सारी सदियां कतार अंदर कतार अपनी जगह खड़ी हो, ये वक्त साकित हो और हम ही गुजर रहे हो? मैं सोचता हूँ क्या ये मुमकिन है, सच ये हो कि सफ़र में हम हैं, गुजरते हम हैं, जिसे समझते हैं हम गुजरते हैं, वो थमा है, ये वक्त क्या है? Although this poem as a whole seems to suggest presentism, which is not what Arya Nagarjuna is suggesting, but I'm sure that it will serve as a food for thought for everyone to start analyzing the notion of time. I would now conclude here and hope that all of you will go back home and try to relive today's conference, even though it has already passed. But what we carry forward is some good imprints and the good merits we have accumulated, somehow bringing us back to the very question I started: does time exist? Thank you, Tibet House.
Thank you so much, Lotus La, for your very courageous covering of Arya Nagarjuna's chapter 19. I'll take the privilege of the chair just to share a few thoughts I've had, because this panel is actually brilliant in the sense that we had Dr. Aravind try to show, as Geshe said in the morning, that at the microscopic level, the reality that we see at the level of ultimate truth, which is seen through ultimate analysis, comes closest to quantum theory. And Dr. Aravind just explained, what are the issues when you try to relate that to the macroscopic level, where you do see unidirectionality of time and all, but this is not perceived at that microscopic level, and what are the challenges that quantum theory is trying to bridge. And as you tried to have shared with Arya Nagarjuna, of course, he going back to the morning sessions where Professor Samtinla brought up, Professor Sisir Royji brought up, that I think at that time, first century scholar who is using the Buddha's words and analyzing through thought experiments and logic is coming very close to what quantum theory is now centuries later talking about. So I think Arya Nagarjuna's work, Mool Madhyamika Karika, of course, is not directly so accessible because it is pretty succinct. All the chapters are very succinct and very, very profound. And I think therefore the entry point is often Acharya Chandrakirti, and you need to access through other scholars who have attempted to interpret it, because if we take it literally, then as you ended, we start going perhaps towards nihilism, and that accusation has been there. But I think, as was said often in the morning's presentations also, that we do accept conventionally what we are experiencing, which all of us do experience time, we are experiencing it. We have to accept that that exists. And I think one of the beauties of Arya Nagarjuna's philosophy and that of the Prasangika is how to completely, go with conventional reality, accepting that reality, while also being able to see the ultimate nature of things, right? Because if we start interpreting the ultimate level as nihilistic, because we cannot correlate it to the macroscopic level or the conventional level, then there's a big danger there. And but as I said, very brave attempt. And I think so exactly what you're saying, that Arya Nagarjuna is not refuting the existence of past, present or future. It's just that through the frame of ultimate analysis, if we go looking for where is that present moment at that deeper level, it is unfindable, which is not to say it does not exist, because with the frame of conventional analysis and at the macroscopic level, definitely it exists. We are all aging and getting closer to death as I keep talking. So with that, we will turn to our last speaker, who is not here with us, but has sent a video recording. Dr. Tenzin Rabga is a postdoctoral scholar in the Department of Physics at Seoul National University. He currently studies the phase transition dynamics in Bose-Einstein condensates of rubidium. Born and raised in India, he's a graduate of the TCV School, Selakwe, and the Mahindra UWC of India. He completed his undergraduate studies in physics at MIT and continued his graduate education in atomic and nuclear physics at Michigan State University, graduating in 2020. For his PhD dissertation, he conducted experiments with radium atoms to probe sources of fundamental symmetry violations in the atomic nucleus. Aside from physics research under the guidance of Venerable Geshe Dorji Damdullah, he also dedicates his time to the study of Buddhist philosophy. In particular, he is interested in the discussions between Buddhism and science and the philosophical implications they have for each other's worldview. So, over to his presentation.
Good afternoon, everyone, and thank you for attending this afternoon session. I'd like to say what a tremendous honor it is for me to be speaking here today. And I would like to thank the organizers, especially Venerable Geshe Dorji Damdullah and the Tibet House India in New Delhi, for providing me with this opportunity to share some of my thoughts on today's topic of discussion. In person, I very much share the underlying spirit and the sentiments of now what is a growing and a continued dialogue between physics and science in general and Buddhist philosophy. With that in mind, I would also like to pay my warmest greetings to the panel of speakers, as well as everybody else in attendance, both in person as well as online. And thank you for taking your time in order to gather here and contemplate on some of these topics, which I think are both very interesting as well as quite important. And so today I've been asked to talk about the nature of time as understood in physics, and I'd like to do that in the following manner. Beginning with time as understood within the Newtonian framework, where time was assumed to have this absolute and uniform nature and I'll explain what each of those terms mean. We will then turn to Einstein's revolutionary idea at the turn of the 20th century, where in his seminal work on special relativity, he fundamentally changed how we think of time, how we conceptualize time within our physical theories, which has since become the standard way of thinking of time in physics. And to illustrate this radical departure from the Newtonian framework, I will explain the now famous twin paradox and show how time behaves in a manner that is quite strange and peculiar, and something that is impossible to infer from the assertions about time within Newtonian physics. Now, it's also quite natural then to ask whether quantum theory, with all its bizarreness, as we have heard throughout today's conference, has anything interesting to say about time. And so I'll provide some remarks in that regard, and then conclude my talk for today. Now, it is difficult to overstate the importance of time in understanding reality, which is why philosophers and physicists alike have spent a great deal of time thinking about it. And Isaac Newton, for instance, was also very concerned about some of these questions about time, such as questions about its nature, whether or not it's a physical entity, and whether or not time depends on things external to time, other than time, for its designation, or whether it has its own independent existence. Now, within his scholium to the definitions in his seminal work, Principia, we see that Newton identifies two different forms of time. One he calls the absolute, or the true time, and the other the relative or the apparent time. So by the absolute time, he's referring to time which exists by its own nature, independent of things external to it, and it flows equably or uniformly in the background while things happen in it. By apparent time, he's talking about, or the relative time, he means time as we experience it. In this sense, we don't have direct access to the absolute time, but we can infer that there is an absolute time that is flowing in the background from the motion and the changes in things that are external to time. So we infer time from, let's say, the changing seasons, or from the passage of night into day and into night, and from the motion of the hands on the on a clock, for instance. So in this sense, he also defines a relative time. Now, it's important to keep in mind that by relative, we mean time that is designated in relation to changes to things that are external to time. In other words, the time that we actually measure, right? And this is not relative in the sense that will come up in special relativity later on in this presentation. Now, this immediately implies then, since Newton accepts the existence of this time, this absolute time that is independent of everything else, that uniformly flows in the background, this then necessarily implies this idea of an absolute simultaneity. What we mean by that is, it is possible then to say things such as, at this very moment in time, we can then specify what each and everything in the universe is doing, where it is, its position and its motion. And everyone in the universe agrees that all of these things are happening at the same time. So time in this sense is common and is something that we all agree on, or this notion of simultaneity is something that we can all agree on. So we can, as illustrated in this figure here, we can make these simultaneity slices where we can define all of space at a given time, and everybody agrees that this is all of space at a given time. Now, Albert Einstein, in his seminal paper on special relativity at the turn of the 20th century, fundamentally rejected this notion of an absolute simultaneity. He asserted that simultaneity is relative. What we mean by two events as being simultaneous is observer dependent. It does not make sense to say that two events are simultaneous with no reference to an observer or an observer's frame of reference or its state of motion. So as a result, it becomes very difficult or untenable to hold on to a notion of an absolute and uniform time if the very notion of simultaneity becomes relative. And that is exactly what Einstein said. He said, our long cherished and innately held ideas of absolute time in the Newtonian sense has to be abandoned, has to be given up in favor of a time that is now relative. Relative in the sense that when we say that a certain amount of time is elapsed between two events, between two things that happens, the amount of time that has elapsed is not universal, is not common to all the observers, but is dependent on the state of the motion of the observer. It is observer dependent. So in this sense, Einstein's idea of relative time is a fundamental departure, a radical departure from the Newtonian formulation. Now, to emphasize this point a little further, let me give you an analogy. Generally speaking, let's say there are two events, somebody departing from Delhi and arriving at Dharamshala. And given these two common endpoints, we would agree that the amount of distance somebody has to cover in order to get from the start to the end depends on the path that the person takes. Now, this is generally accepted wisdom. In special relativity, it is not only the distance, the physical or spatial distance, but also the temporal separation between two events that is path dependent due to the relativity of simultaneity that we just spoke about. So therefore, the amount of time that has elapsed between two events has no meaningful absolute sense. And it really depends on who is measuring it. In other words, it really depends on the trajectory of the clocks that are measuring the separation, a temporal separation between these two events. So now let me give you an illustration of some of the abstract things that we've been discussing so far. And so we're going to discuss the twin paradox, and nothing really challenges our innate notions of an absolute time like the twin paradox. And in some sense, it highlights some of the crucial features of Einstein's arguments in his new theory with regards to relative time and his dismantling of our widely cherished, long cherished notions of an absolute uniform time. So we start off with two twins, X and Y. One of them, twin Y, decides to take off on an excursion on a rocket with speeds dangerously approaching significant fractions of the speed of light. Right. After given a certain amount of time, twin Y decides to turn around and head back towards Earth. And so they eventually meet on Earth, and to their amazement, they find that one of the twins, twin X, was always remained on Earth, has aged significantly more than twin Y, who's just returned from his round trip around the galaxy. But then you might ask, wait a minute, so how much time has really elapsed between these two events, between the two twins meeting? Can we in any sense answer that question? But we know from relativity now that there is no absolute answer to that question. It is a relative statement when we say a certain amount of time has elapsed between two events, as is evidenced by the biological aging of these two twins, that the biological clock, if you will, registers the amount of time that has elapsed between these two events differently based on the trajectories of the two twins, on the different trajectories of the two twins through this fabric of space-time in which everything happens. And this is, in a sense, the remarkable feature of Einstein's theory that is fundamentally different and it's a radical departure from our innately held ideas of how time behaves, how time flows, or our innately held assertions about the nature of time, that it is in fact very, very strange and not something that we're innately programmed to perceive or even comprehend. So this, in a nutshell, is an overview of how our notions of time have evolved from the Newtonian conception of an absolute and uniform time to Einstein's radical departure and assertions of a relative and a more dynamic time. Now, some of us might wonder, given the inherent strangeness of quantum theory, whether or not it has anything significant or interesting to add with respect to the nature of time. Now, as far as the standard formulation of the theory goes, in my limited understanding, I don't think there is anything remarkably significant that it has to say with respect to time. As it happens, generally speaking, given the regime in which the theory is operating, whether we are dealing with systems that are relatively non-relativistic, we usually adopt the notion of time as is present in the Newtonian formulation, driven mostly by the need of the hour, practical needs of the hour. But when things do become fast enough, when relativistic effects become important, then necessarily we have to make our quantum theories compatible with special theory of relativity. And in that sense, the relativity becomes important. And this gives rise to what is called quantum field theory, which is the backbone of pretty much all of our particle physics. But nevertheless, by and large, the notions of time that are present in quantum theories are what are already present in pre-existing theories in classical physics. So quantum theory by itself does not have anything, does not appear to add anything new, at least at that level. Nevertheless, I think we can ask certain interesting questions and bring them up for discussion with respect to how quantum theory does or does not treat time, right? For instance, within the classical framework, where which are by nature deterministic, we can assign temporal designation to objects. We can talk of their past, future, and present, and we can very clearly infer a continuum, a causal continuum, deterministic causal continuum between these three temporal events. But this becomes quite difficult in the quantum framework because within quantum mechanics, at the moment of measurement, at least in the standard formulation, at the moment of measurement, indeterminacy creeps in. So then we can ask, what does this imply in terms of the in terms of the temporal designations that we make on the objects? We can also go a little further and ask whether or not the notion of a singular actual future is compatible with this quantum indeterminacy, and other questions of this kind, right? Which I think are quite interesting. And in quantum mechanics, the physical observables, or the quantities of interest, are represented by what are called operators, right? But insofar as I know, there is no time operator. So what does this mean? Can there be a time operator? As far as I know, certain arguments by Pauli and von Neumann prohibit such a notion, but this is probably up for debate and discussion. But if there is no time operator, then what does that mean? Is time then a physical quantity within the quantum formulation? Is such an idea even tenable in the first place? So I think these type of deep and interesting questions can be raised within quantum theory as well. Yeah. And so this basically sums up my talk. But I wanted to end with some questions that I think can be also asked of the Buddhist theories with respect to how time is explained in their philosophical schools, specifically how the Buddhist understanding of time compares to the Newtonian and the Einsteinian notion of time, whether or not within the different tenets of Buddhist philosophy there is a resolution to the twin paradox, how time is experienced by different clocks in different trajectories can be explained within the Buddhist philosophical understanding of time, and how does the relativity of time, as explained by Einstein, fit into the dependent origination, the theory of dependent origination, as explained in Buddhist philosophies. With that, I will end the talk, and thank you all for listening.
Great. So that was a wonderful recorded presentation. So we'll take a few questions from the floor now. I think even the younger audience is waiting for tea. But if anybody has any queries. Ben.
Hi, me again. Lotus Namgail, could you elaborate on why Nagarjuna said that if present and future depends on the past, then the present and future exist in the past? Why did he say that?
I thought I tried to explain myself, but all right. So he is saying that he is trying to refute the dependence, refute the arguments that is coming to him, where he is trying to refute the arguments wherein that present and future exist in dependence on the past. So let's say if, according to the first verse can be translated as I already told you, that it is somehow same as saying that present equals past if it is dependent, because both the relator has to be present in the same moment. That is how dependence work. Are you following me?
My old age is dependent on my younger days.
See, your age is what? What did you say? Yeah.
So I said that my current age, not old, yeah, older. So now I'm 33 years old. It depends on me being 32 years old before.
Yeah.
It doesn't mean that it exists at the same time.
So I'm not talking about that dependence. Dependence in terms of existence. See, Nagarjuna is what? Yeah, Geshe-la, I would rather explain it. See, he is not actually refuting the conventionality of time. He is as Professor Kaveri also reflected, that he is trying when we try to look into the time, let's say present moment, we have to do it into past, into at least three different times. The present moment related to the past, the present moment related to the future, and a middle between that. So you cannot find the present moment intrinsically.
Actually, the time is also passing when you were saying that I'm receiving it. That's only this uncertainty level you were saying. You can't actually get. Sorry. So whenever you try to talk about the present is gone. So in that sense, you can't actually, in a very solid sense, can't stay in the present. Never. But what you were saying, this does not mean that what you were saying is wrong, because you were 33 years of age, but within uncertainty level. That is what I was also talking in my talk, if you remember, that every time when you argue about a physical process, you always talk about some uncertainties. But with that, you can't work in science. In science, you approximate that as an exact logical statement, and then you work on it. But then again, when you question that what is it that I'm talking about, then you need to go back to the process. And when you go back to the process, what you see is everything is spread out. Right? So in that sense only. So it is neither of you are absolutely correct. You can question it. He will not be able to answer it with the extreme satisfactory level to you. But if you then think that, okay, I am now right, then you will see that there is a wrongness in it as well. So it's always in the middle. Okay.
Shall I add a point? Just a statement from my side. Well, what I can understand with the notion of time, when I think from the perspective of memory or mind, so what I am with my memory right now is essentially the collection or the accumulation of past. So the present indicates the past. So present is the accumulation of the past. And what the mind thinks about the future is essentially the projection of this present, which I call the accumulation of all past. So essentially, in terms of memory and mind, the idea of present, past, or future is essentially the movement of thought backward or forward. So this is what I can understand. Sorry for the confusion if I...
I think what Benna asked, I think we have to stick to what he asked. What he asked is that the present moment, whatever age he, 33, and that he was 10 years old, or that he was 13 years old 20 years ago. So these two don't coexist, and this is reality. So I'm going to say that if they exist as intrinsically, that these two should be together, and then if they are dependent on each other, these two should be together. Why? So this question we should stick to that. We cannot give so this question asked, answer should be totally unrelated. So this question asked, so how if the present and the past when he was 20 years younger, so if these two are dependent on each other, what he is today is because of what he was 20 years ago. So these two are dependent on each other. So why is it that the two should be together? Why? This is the question. So in this regard, so basically the idea is that Arya Nagarjuna, as very clearly indicated by Professor Kavirji and the Lotus Namgail, that if there's intrinsicality there, then the dependency is rejected. If the dependency is not there, then what exists should forever exist. What does not exist should never exist at all. So because of which, if the past exists, it should exist forever. And if the present should exist, it should exist forever, in which case the two should coexist at one point. If that is the case, then the dependency would make no sense. So this is where the two things are, two different entities, and the dependency is rejected if the two things coexist at one point and intrinsically. Yeah, thank you.
Thank you. My question was for Professor Aravind. If the quantum field is not unidirectional or linear, and we posit from whatever little I understood, I'm not a quantum, obviously a scientist, but we posit, and we are not able to fully understand how the unidirectional linear formation of time exists. Will science, from the science point of view, if you're able to solve for that, will we be able to go back in time, potentially?
What I meant was that at the subatomic level, or in other words, at the quantum mechanical level, the unitary dynamics dictates that you cannot distinguish between the future and the past kind of thing. Whereas in the microscopic world we can. So the answer, one of the answer out of many, is that why it is, if you ask, there is a coarse grinding. Means my observation are incapable of getting all the details of the microscopic constituents. So that's the answer. Okay. So if I am the question is that am I able to get the details of this one? It is kind of impossible. Means it is very difficult. For example, the number of subatomic particles is too huge. So such a question, whether can I go back or other thing, doesn't make any sense at the language of quantum theory.
Krishna, if I may just take the privilege of the chair, just because there are physicists here, just to ask you that there is so much money being spent on research on time, trying to arrest it and other things. So do you see any, sense in that, or Professor Cicero? And because there is a lot of energy going in, at least at the commercial level, trying to stop aging and all these kind of things. Do you see any sense in that, or really it's a bit of a futile exercise? I just wanted to ask.
Yeah, I mean, aging simply it indicates there is unidirectionality of time, because it's a kind of macroscopic phenomena. I don't know what is happening at the subatomic level. Okay, so of course we should try to understand that aging is a fact. I mean, at the conventional or whatever we say ultimate level, in my view, I mean, if you be enlightened in such a manner, for that nirvana is, it's meaningful. For me it is not meaningful, because I have not reached to that state. I can say in language, but that's sake of language.
Thank you so much. So thank you to the panelists and all the participants, and we will break for tea, and then we will come back for the very exciting student panel. Thank you. Thank you so much.
Hello. Thank you, everyone. And I believe you all must be very tired. Therefore, I will be quick. Now, I would like to request Ajirji to present souvenir and Tibetan traditional khatas to our respected speakers and to our chairperson. Professor Kavirigila. Assistant Professor S. Aravinda ji. And Senior Research Fellow Mr. Lotus Namgail. Before we recess for tea and refreshment, I would like to request all of you to kindly join us for the most appealing session, the student panel discussion, where the young minds will share their pretentious experiences, and we really appreciate your presence. Thanks so much. And the next moderator will be my colleague, Mr. Tinsley Legmila. Thanks so much, everyone.